Hello learners, welcome to Hope Channel Kenya. This is your favorite program, Knowledge Quest. My name is Mr. Aguk Sam, ready to take you through mathematics lesson. In our previous class, we were learning on statistics. We had discussed various concepts under statistics. We mentioned how to calculate the mean, how to calculate the standard deviation, how to calculate the variances. And today, I want us to discuss on how to calculate the median. That is the aspect of this class today. I want us to discuss how to calculate the median, how to calculate the quartiles, how to calculate the quartiles, how to calculate the deciles, and lastly, how to calculate what we call the percentiles. I hope everybody is ready. You are ready with your book, with your pen, and with your calculator. So get ready and let us start the class. So briefly, we were discussing how to calculate the mean of a group data and also the mean of ungroup data. We also mentioned how to calculate the variance both for a grouped data as well as ungrouped data. We mentioned also how to find or how to calculate the standard deviation as well as the mean absolute deviations of both the group data as well as ungrouped data. If by bad luck or you were busy during our previous class and you were not able to catch up with how to calculate the mean, how to calculate the variance, how to calculate the deviations, what I will advise is that just go to our YouTube channel. You will find a series of all those classes uploaded so that you can watch and keep interact with us. So that whenever we continue with the lesson, it will always form or it will always give you a backup. So today I want us to begin discussing the median. And I have a data here. So we are provided with a data here. We have class and also we have the frequency. So the first class begins from 1 to 5 with a frequency of 6, 6 to 10 with a frequency of 19, 11 to 15 with a frequency of 13, 16 to 20 with a frequency of 20, 20 to 21 with a frequency of 12, 26 to 30 with a frequency of 11, 31 to 35 with a frequency of 6, and lastly 36 to 40 with a frequency of 5. So this data, we are going to use it for our class today. We will calculate the median, we will calculate the quartiles, we will calculate the deciles, as well as the percentiles using this particular data. In addition, we will also be discussing or we will also be looking at how to calculate the median, quartiles, deciles, and percentiles of ungrouped data. So let's begin with the first one. So we begin with the median. So let's begin with the median. Yeah, some people always call it medium. Actually, it is not medium. The best, or it is the median. Median divides a set of data. So this one we say divides a set of data divides a set of data into two equal parts, into two equal parts. So a median will divide, it is that observation that divides a set of data into two equal parts. Actually, they say the middle item. So if somebody asks you to find the median, in simple term, they're just asking you to find the median or the middle item. The middle item. So how do we get the middle item? So we say the middle item or the median item. So we call it the middle item or the median item. The median item is always obtained by using this formula, n plus 1 divided by 2, where n is equals to the total number of observations. N is the total number of observations. The total number of observations. So that is what we call N. So meaning that if you have a total of maybe 9 observations, if you have a total of 9 observations, we have a total of 9 observations, and we want to know which observation is at the middle. We say that we just say 9 plus 1 divided by 2. So 9 plus 1 in this case is 10. 10 divided by 2 will give us what is called 5. So the fifth item is the item in the middle, and that fifth item is the median. Let's use an illustration. Supposing that the heights of students in a class, is provided as follows. So the heights of students in class are provided as follows: 140, 152, we have 160, 138, I don't know who is that, who is 138 centimeters tall, so these are heights in centimeters. Then we have 154, we have 156, we have 162. So these are how many students? 1, 2, 3, 4, 5, 6, 7. I want them to be 9. 7. Then maybe 139. Then 142. So these are the heights of students in a class. So you are asked to find the median. So we are asked to find the median. So how are we going to find the median? We say the median is always given by n plus 1 divided by 2. So n is the total number of observations. So let's count how many observations we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 observations. So we want to know which data is in the middle. That is the median item. So what you need to note before you even ask yourself which number is in the middle, statistical data require what we call arrangement. So you need to sort your data in ascending order first. Arrange them in the order from the smallest to the largest. So first of all, we begin by sorting this data. We start by arranging it from the what? From the smallest to the largest. So let me see which one is let's get the assorted data. The smallest here is 138, followed by 139, followed by 140, 152, 154, 156, 160, 162. 162. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. So there's a data we have left. Which ones have we left? So we have 138. Good. 139, 140, 152, 154, 156, 160. Oh, there's 142 somewhere. We have left it. Okay, so this 142. Let me say 138, 140, then 142. Okay, that's it. 142. So we have all the data with us. 142 we didn't include. So 1, 2, 3, 4, 5, 6, 7, 8. 142. Which one is missing? Oh, 140, 142, 138, 140. Oh, 139. Sorry, 139. I've not returned it. Then 140. Then 142. Good. So we have all our data with us. We have all our data with us. So it is always the first step. Ensure before you even find the median of a group data, your data must be sorted. You must arrange it in the order or in ascending what? In ascending order. So once you have done this way, we want to know the median item. You know, some people can do it this one manually. I know some people will always do it manually by counting. There are 9. So which one in the middle? 1, 2, 3, 4, 5. This number 5. So 1, 2, 3, 4. So automatically this one is the number in the middle. That is the median. Actually, you can do it very simply. But now let's see how this formula works. N plus 1 divided by 2. So N is 9. So the median item is N plus 1. So we add 1, then we divide by 2. So that is the 5th item. Yeah. So our work will be very simple. You just go now count. Count the observations. 1, 2, 3, 4, 5. So observation that will fall on number 5. That is the median. So like in this case, 1, 2, 3, 4, 5. So this is the median. So the median, therefore, our median in this case will be 152. I hope we have gotten it clear. Somebody will work with it manually. Just count, use your eyes, know which one is in the middle. But now the biggest question we are asking ourselves is that if you are going to count, assuming that you have hundreds of them, or you have a data that is having a total of 200, will you be able to see which one is in the middle? So that is where this formula becomes very much practical. So we'll know which one exactly is in the middle. So as I said, the median item is N plus 1 divided by what? By 2. I know somebody is asking, Mwalimu, what about if these observations were not 9? They were 10. We can also do that. If these observations were 10, the formula still applies because it will be 10 plus 1 divided by 2. So 10 plus 1 is 11. 11 divided by 2 is 5.5. So assuming that I add another data here, maybe 168. I add another data there, 168, to make it now 10. To make it now 10. We see how this formula is working. So we say 10, also you add 1, you divide by 2. So when you take 10 plus 1, you divide by 2, you get what? 5.5. So this 5.5, how are we going to calculate it? 5.5 means that it is between 5 and 6. So just come here, count. 1, 2, 3, 4, 5. Then there is 6. So it is not 5, but it is 5.5, meaning that it is between what? 5 and 6. So in such a case, you will be saying that the 5.5 item will be between 5 and 6. So this point means that it is not exact. It is in between. in between. So you'll just take that 152, you add to 154, then you divide by what? You divide by 2. So that one will give us 153. So that one will become our what? That one will become our median. Are we together? So if it is an even number, for example, 10, you still use the same formula. If it is an even number, it shows you that this data is in between. It is not only singled out like when it is an odd number. That is very nice, and that is how we calculate the median of ungrouped data. So this one is always a very easy thing that you can always do at your good time. So with our series of questions, our series of illustrations, we will be providing you more and more practice questions so that at least when you are now alone, you can also practice this and see how it is being what? It is applying. Very good. Having done with a median of ungrouped data, what about now if we are dealing with a what? A grouped data. A grouped data, we said in our previous class, that is a data that is arranged into classes. So this data, like the one we have here, this is a group data because the observations are organized into classes. Each class given a specific frequency. So how do we find the median? So let's work on that. You'll allow me to rub this. So let me just rub this one here. Let me just rub that. Good. So median of a group data, median of a grouped data. If a data is now grouped, how do we find the median? So the best way of finding the median of a grouped data is using the formula of the median. So what is the formula? The formula is given by lower class boundary plus n all over 2 n all over 2 divided by f, everything multiplied by I, which we call the class interval. So let's see what everything here mean. When we talk about LCB, we mean the lower class boundary. We had mentioned how we calculate the class boundaries in our previous class. So the lower class boundary of the median class. The lower class boundary of the median class. The lower class boundary of the median class. N in this case is the total number of observations. The total number of observations. The total number of observations as we had seen in the previous example. CF in this case is cumulative frequency. So we talk about cumulative frequency above cumulative frequency. The key word here is above the median class. Cumulative frequency above the median class. Then we have F. F in this case is the frequency. F in this case is the frequency of the median class. Frequency of the median class. Frequency of the median class. Then I in this case is the class interval. I in that case is the class interval. So that is what each and every abbreviation in that formula stand for. So what comes out clear from this particular formula is that we cannot find the median if we don't know the median class. Everything here is about the median class. Means that it is always very important that we start by finding the median class. In other words, we will have to ask ourselves, between these classes, which class is in the middle. Good thing, or what is important with the most of these group data, they are always sorted. Already it has been arranged in ascending order. So we are not going to rearrange them again. But now the biggest question is, which class? How are we going to pick? How are we going to pick which class is in the middle? We don't do it randomly. We have a formula of doing that. So median class. So the first thing you're supposed to do, when you are calculating the median, the first thing you're supposed to do when you are calculating the median is called the median what? The median class. So how do we get the median class? As always, we need to get the median item first. We need to get the median item first. So we need to get the median item first. So how do we get the median item? So we say n plus 1 divided by 2 will give us the median what? The median item. So we need to calculate the total frequency. Are we there? So we need to work out with the total frequency. So how are we going to get the total frequency? It is very, very, very easy. Kwa data nimepewa like this one, when we are having this particular data, we need to introduce, in this data, we need to introduce what is called cumulative frequency. Cumulative frequency column is going to help us add all the frequencies. The cumulative frequency column is going to help us add the frequencies so that we will know how much or what is the value of A or what is the value of N. So let's add the frequencies as we move down. So this one is 6. So 6 we add to 19. 6 plus 19 will give us what is called what? 25. So we continue adding them as we go down. So 25 plus 13, that will give us 38. 38 we add to 20. We are accumulating the frequency. To accumulate means to add. So we just add the frequencies as we move from one class to another. So 6 plus 9 will give us, because at the first one we only have 6. Then the second class has 19. So 6 plus 19 will give us what? 25. 25, if we add to 13, should give us 38. That one should give us 38. So 38, we continue that way. 38, you add to 20. 38 plus 20 will give us 58. So 58 now we add to 12. 58 plus 12. What will we get? We will get 70. 58 plus 12 will give us 70. 70 now plus 11. That one will give us 81. 81, we add what? 6. 81 plus 6 will give us 87. Then 87, when we add to 5, 87, when we add to 5, we get 90 what? We get 92. Are we together? So you can prove that. You can prove that by taking your calculator, add all the frequencies if they will add up to 92. So 6 plus 19 plus 13 plus 20 plus 12 plus 11 plus 6 and plus 5. We get the total as what? 92. So that is how we fill the column of cumulative frequency. So that's the only class that we need, or that's the only column we need to calculate here. So once we have gotten the cumulative frequency, or the total frequency as 92, so we need to know which item is in the middle. That is the median item. So we simply come and say 92 plus 1 divided by 2. So 92 plus 1 divided by 2. So 92, that is 93. 93, when we add, we are going to get 46.5. Good. So item number 46.5. item number 46.5. That is the item in the middle, or the item in the middle. So let's look at where is it. Where are we going to find this? We go back to our column of cumulative frequency and ask ourselves, where is 46 falling? So like we can see, 6, 25, 38, 58. So from 38, we go to 58. But what do we want? We want 46. So 46 is above 38, so we cannot say here, but 46 will be found here in 58. So meaning that this is where the median is going to fall. We get it, eh? So we don't just go choose randomly the way you are doing with the ungroup data, that we just count and see this one is in the one in the middle. For our group data, we need to know the total frequency first, and after identifying the total frequency, we use the formula of finding the median item, which is n plus 1 divided by what? Divided by 2. So in such case, once you found the number, go back to your column of cumulative frequency. Actually, that is why we were accumulating these frequencies, because we wanted to know exactly where does it fall? Where does it fall? Yeah, that is what we look into. So like in our case, we are 46.5. We are going to ask ourselves, where is 46.5 falling? So we can look into here. From here we have 38, and here we have 58. It simply means that 46.5 is in this class, because by 38 bado hatujafika kwa 46. So it will just be in this class. So this is our class of reference. So it means that our median is going to fall. Our median is going to fall between what? 46 and what? And no, between 16 and 20. Yeah, so if we are going to calculate our median, definitely at the back of our mind, we know that any answer between 16 and 20 is correct. But if we find an answer which is outside these limits, then definitely our answer is wrong. So this is where the median falls. Good. So how are we now going to effect this one into our formula? Remember, the formula is stated for us to calculate the median. The median is the lower class boundary. Remember, the lower class boundary, we have said it is the class boundary of which class? Of the median class. It is the class boundary of the median class. So we need to look at the boundary of this class. So we simply say median. Let me rewrite the formula. As a good student, you are always supposed to know, you are always supposed to rewrite the formula every time you are doing. A moment as you continue rewriting the formula, you get used to it. So the formula is a lower class boundary plus n all over 2 minus cf into I everything divided by f. So we are taking a very short break. Then we come back and work out this problem. So as we break, somebody who has understood the concept, you can move ahead and find your answer. Yeah. Okay. So welcome back to this lesson. We stopped at a point where we were asking ourselves how to find the median. And I believe that some of you have gone ahead and even found the answer. For those people who have not gone ahead, don't worry. We are still here with you. We are going to do it together now. My name is Mr. Aguk. So let's continue. We said we need to start with the lower class boundary. We need to start with the lower class boundary. So what is the lower class boundary of this class? the lower class boundary, we say that if this one is ending at 15 and this one is beginning at 16, the boundary is just between 15 and 16, which is 15.5. So we just say here is 15.5, then plus. Now, let me make this easy for you. This section of n divided by 2, this section is in this formula to help us know. This section is in this formula to help us know which item is in the middle. And because we have already worked it out, so you don't need to say G92 divided by 2. Just pick that item you got there. So you just come here and say this is just 46.5. So you don't need to work it out, because the item we have asked, this n divided by 2, it is that formula that we extended here. Are we there? It is the formula that we extended here to help us know which item is the middle. And in our case, our middle item is 46.5. So don't come here, say 92 divided by 2 to get 46. Because we all know that for an even number like this one, there are two numbers in the middle. So if we have 46, we should also have 47. So instead of finding for 46, and also going ahead and also finding for 47, the 46th item and the 47th item, there is no need. In a simple term, just find the average of 46 and 47, you still get what? 46.5. So don't move ahead and substitute here. Just use the middle item that helped us to get the median item. So minus CF. CF, in this case, we said is cumulative frequency above. Cumulative frequency above the median class. So this is our median class. The cumulative frequency above this class, is what? 38. So you come here, subtract 38. Subtract 38. Yeah, cumulative frequency above the median class. So there's a reason why I was marking out this class. So I was marking out this class so that I can be able to actually identify which is the frequency above. So CF is the cumulative frequency above the median class. Cumulative frequency above the median class. Everything divided by F. F is the frequency of that class. So this class, this is our class. The frequency in this case is what? 20. So we divide by 20. Then after dividing by 20, we multiply. We don't forget to multiply by the class interval. That is I. So what is the class interval between 16 and 20? In our introductory class, we calculate, or we checked, or we looked into ways on how we can calculate the median, the class interval. We said you can count it manually. If somebody don't believe in formulas, you can say 16, 17, 18, 19, and 20. So because 16 to 20, those are 5. So just come here, write 5. Alternatively, you can use the formula upper class boundary minus the lower class boundary. The upper class boundary here is 20.5. The lower class boundary here is 15.5. So 20.5 minus 15.5 will give you 5. The only mistake we said we are not supposed to do when we are calculating the class interval is just subtracting the limits, like saying 20 minus 16. That will not give you 5. Instead, it will give you 4, which is not correct. Reason being, in such a case, both 20 and 16 are included. So that is it. So let's work out this one and find the median very fast. So we work out this one in the bracket. We say 46.5. We subtract 38. That gives us 8.5. 8.5 divided by 20. Or let me just write for the sake of others. 15 plus. So inside the bracket, we are going to have 8.5 all over 20. Then we multiply by 5. So 8.5 divided by 20 is giving us 0.425. Multiply by 5, we get 2.125. This is 15.5. So this one will give us 15.5 plus 2.125. So this one, when we add 15.5 to the answer, we get 17.125. And that is the median item, or that is the median. So we say that our median should be between 16 and what? And 20. And from what we can see here, the answer is 17. So meaning we are very much correct to this particular information. So as a reminder, for you to calculate the median of a group data, we said the first thing you're supposed to do is to calculate the median item. The median item, we said, is n plus 1 divided by 2. Once you've gotten the median item, go to your column of cumulative frequency. Go to your column of cumulative frequency, identify where your median item is falling. Once you know where it is falling, the next thing that you are supposed to do is to mark out that class. That class will be your median class. That class will be your median class. So with your median class, you can now substitute everything into the formula. The lower class boundary plus n divided by 2 minus CF divided by what? F into I. Remember, CF is the cumulative frequency above. Then F is the frequency of that class. And that is how we work out the median. So everything here remains the way it is. So in our sections, we will be providing, in our platforms, we'll be providing more practice questions to help you know, or to help you master the concept. So I hope everybody is okay. If you have a problem that is also creating, or is also giving you a very big challenge, you can post it in our social media platforms. We will be able to work it out and share the answers. So let's go to quartiles. Okay, now we are going to quartiles. So let's move to quartiles. Quartiles. Okay. The concept of quartiles is very easy once you've understood the concept of median, because this formula for median is the same formula we use for quartiles. The only thing that changes is that a quartile is dividing a set of data. A quartile is dividing a set of data into 4 equal parts. Yeah, that is the only problem, that's the only difference. But everything else remain the same. So quartiles, so let me just write here, quartiles. So a quartile is going to divide a set of data, divides a set of data into 4 equal parts. A set of data into 4 equal parts. So we have 2 types of quartiles. The first part is called the lower quartile. The lower quartile in this case is the first quartile. We always call it Q1. Q1 is the first quartile. The first quarter in this case, we say that a quarter of n. So a quarter of n. So this is the item we are going to look for. Then the second one is the upper quartile. The second one is the upper quartile. The upper quartile is the third quartile. Yes, because we have quarter 1, quarter 2, quarter 3, quarter 4. So the best ones that we always look into, because quarter 1 is lower, quarter 2 is the median, then quarter 3 is now what we are calling the upper quartile, the Q3. So it is that the third quarter. So it is the third quarter of that data. So if anytime we are going to calculate the upper quartile, we are looking into the third quartile. Then there is something also we call quartile range. Yeah, so there's something we call quartile range. So quartile range in this case is the same as the upper quartile minus the lower quartile. That is Q3 minus Q1. Then we have what is called quartile deviation. Yeah, we also have what is called quartile deviation. Quartile deviation is also referred to as semi-interquartile range. Yeah, semi. Yeah, so sometimes you'll find somebody is asking you to find the semi-interquartile range. The semi-interquartile range is also known as the quartile deviation. So these are the terms which are used interchangeably. So maybe you have learned, or maybe you shall have learned quartile deviation. Then you meet somebody asking you to find a semi-interquartile range. Then you think they are different things. So that's the same things. So you simply say a half. It is semi means a half. A half of Q3 minus Q1. A half of Q3 minus Q1. So in order to calculate the upper quartile or the lower quartile, we need to use the same formula that we use in the median. The only thing that changes is that in the median, the n was over 2. But now in the quartiles, the n is going to be over 4. So we are going to use this one. We are going to use this grouped data here to give that illustration. So let's use this group data here to give that illustration. So let me begin with the lower quartile. That is Q1. So let's begin with the lower quartile. That is Q1. So Q1, we say that we need to find a quarter of n, which is a quarter of the total. The total here is 92. So a quarter of 92. A quarter of 92. A quarter of 92 is 23. So meaning that it is 23rd item. Yeah. So our lower quartile is falling on the 23rd item. So we will come here and ask ourselves, the same way we were asking ourselves in the median, where is 23 falling? Remember that case we were asking where is 46, but now here is now 23. Where is 23 falling? So 23 is going to fall here where we have 25 because it is above 6. So this one will be my Q1. Let me just label it. My Q1 class. Because we need to get that class first. The same thing we are doing with the median. We get the class what? First. Once we have gotten the class, then we are now good to go. Because we will be working with the same formula. So we are going to say Q1 is same as lower class boundary into now. You can see this. In the formula for mean, or the formula for median, you are saying n divided by what? 2. But now it is n divided by 4. It is now n divided by 4. That's the only thing that changes in that formula. So let's continue. So the lower class boundary of that class now. The lower class boundary. Yeah. So this is now not median, but lower class boundary of the quartile class. Above the quartile class. So everything now change here to quartile. Frequency of that now quartile class. Frequency of that Q1 class, whichever one you want to call it. So everything remains the same. So what is the lower boundary? This is 5, this is 6. So boundary is 5.5. N divided by 4. I say this one we don't need to calculate. It is the one that we always calculate first. So our work is just to insert it. So n all over 4 is just 23. Then minus CF above. CF is the cumulative frequency above. So this is the quartile class. So cumulative frequency above here is what? 6. So it will be 23 minus 6. 23 minus 6. Everything divided by f. F is the frequency of that class. The frequency of that class is 19. Then this one we had already calculated. We have said the interval between 6 and 10 is 5. So our work is now very simple. We just calculate this one out. We say 23 minus 6 is equals to 17 divided by 19 is equals to 0.89 times 5. I've just worked out the other part. Yeah, so that this is 5.5 plus 4.5 rounded off. So when we add 5.5 to this, we get 9 point. And that is 10. Let me just averagely 10. 9.9. That is just 10. So that's our Q1. We can also go ahead and calculate Q3. We can also go ahead and calculate Q3, which is the upper quarter, the upper quartile. So upper quartile, our Q3, we said is now the third quarter of n, a third quarter of 92. So let's get the third quarter of 92. 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 So 69. So item number 69. 69th item. 69th item. 69th item. Good. So where is 69 falling? The same thing we have been doing. 69 is falling, it is above 58, so it is in this class where we are having 70. So this one becomes our what? Our Q3. That one becomes our Q3. So we come and say Q3, the same formula. I always encourage you to write formula always. But now we are not going to say n over 4, but we're going to say 3n because now the third quartile. So minus CF all over what? All over F. Everything you multiply by the class interval. So we have said the lower class boundary. Now that people have now seen the way, they can always work this thing very fast now. The lower boundary, this is 20, this is 21, that is 20.5. 20.5. The lower boundary, in that case, is 20.5. Then we have 3/4 of n, 3/4 of n, which we have already calculated as what? 69. We said this one we don't need to be stressed because the first thing we always calculate. Your work is very simple. You just what? You just put it in. Then CF is the cumulative frequency above that class. Cumulative frequency above this class. This class has a cumulative frequency of 70. Above it is what? 58. So subtract 58, then divide by the frequency of that class. Frequency of that class is 12. So we divide by 12. Then we check on the class interval. The class interval between 21 and 25 is still 5. So this one gives us 20.5 plus.
Cut. Hapo 3 and over 4 inafaa iwe 69.
Oh, it's okay. Back in how many minutes?
Back how many minutes?
5, eh? Okay. Okay. So the lower class boundary of this class, we said some people have now known it. This is 20, this is 21. We are going to have 20.5. 20.5, we add to 3/4 of n. We said this one you have already gotten because it is always the first thing that we calculate, which is now what? 69. So we'll just say 69 minus the cumulative frequency above, CF above. CF above is 58. So we subtract 58. We subtract 58, divide by F. F is the frequency. F is the frequency of that class, which is 12. We divide by frequency of that class, which is 12. Then everything multiplied by the class interval. The class interval, we have said between 20 and 25 is still what? Is still 5. So our work is just to work this one out. Our work is just to work this one out. So 69 minus 58, that is 11. 11 divided by 12, that is 0.91. Then times 5, we get 4.5 or 4.6. Let me just round them off to the nearest one decimal place. So that is 4.6. So 4.6, if we add to 20.5, we are going to get 25.1. So 25.1. So this is what we call the what? The upper quartile or the Q3. So finding the quartiles is always very easy. It is a very similar way we calculate the median. So the moment you've understood how to calculate the median, it will be very much easy for you to be able to calculate the quartiles. The concept is the same. The only thing that changes is the what? The only thing that changes is the division here. Median divides into 2, but now quartiles divides it into 4. So the same formula we are using to calculate the deciles, to calculate the percentiles. So if it is deciles divides a set of data into 10 equal parts. So here you just come and say divide by what? By 10. Are we there? So like if somebody asks you the 5th decile, mean that it is now 5 over 10. That's the only thing that changes here. Percentiles, the same case. Percentiles means that the data is divided into 100 equal parts. So if somebody asks you the 70th percentile, mean that it is 70 over 100. So whatever will be changing in this formula is just 70 divided by now what? 100. So 70 over 100 n. That's the only thing that changes in that formula. You can use this formula to calculate the deciles. You can use that formula to calculate the percentiles. You can use it to calculate the median. You can use it to calculate the quartiles. So lastly, as we wind up, we can now get the quartile deviation. So as we wind up, we can calculate the quartile deviation very fast, which we say is a half of Q3 minus Q1. A half into Q3 minus Q1. So Q3, we have gotten it as 25.1 minus Q1. Q1, we have gotten it, where's our Q1? Or Q1, we gotten it as 10. So 25.1 minus 10 is 15.1, then multiplied by a half, give us 7.55. 7.55 is our quartile deviation. So if you're asked to find the quartile deviation, or what we are calling the semi-interquartile range, sometimes we call it semi-interquartile range. So if you're asked to calculate the semi-interquartile range, or you're asked to calculate the quartile deviation, you just say it is a half of Q3 minus Q1. Q3 minus Q1 alone is just the quartile range. But now deviation is a half of that. And that is what we have in calculations of median, calculation of deciles. I've also given you how you will use the same concept to calculate the deciles, calculate the percentiles. In our other series, you'll also be learning how we can calculate the median, the quartiles, the percentiles, as well as the deciles using graphical illustrations. That is, using what is called cumulative frequency curve. So you can use the cumulative frequency curve without going to head with this formula and calculate the median, the quartiles, the deciles, as well as the what? The percentiles. So I hope you've gotten some concept, and I believe that you've understood everything as it is in calculating these statistical measures. As a summary, I've said that for the class, if you missed a class, you'll always find some recordings on our YouTube channel. I think most of these things have already been discussed. Others, we are going to post them out as questions. Thank you, and may God bless you.